Hello everyone, welcome back to my YouTube channel Learn with Sumi. Okay, in this video, I am going to solve this problem. The problem is stated as if phi is equals to log of x square plus y square plus z square, then find del phi and magnitude of del phi at the point 1, 2, 1. Okay, so let me rewrite the question. So given is phi of x comma y comma z equals to log of x square plus y square plus z square. Correct? So this we already know. Gradient phi, grad phi is also represented as del phi, isn't it? So del phi is, this can be written as dou phi by dou x into I plus dou phi by dou y into k into j plus dou phi by dou z into k, right? So using this, differentiating phi partially with respect to x, y, z respectively, we get, let me first differentiate, with x, with respect to x. So if I'm differentiating log, I'm differentiating partially with respect to x, right? So this is going to be, differentiation of log is going to be 1 divided by x square plus y square plus z square. I hope it is clear, and as it is with respect to x, only differentiation of x square. Done. Now dou phi by dou y equals to, this is going to be same, 1 divided by x square plus y square plus z square into 2y. Similarly, dou phi by dou z equals to 1 divided by x square plus y square plus z square into 2z. Correct? Now at the point, we know that the point is given at the point 1, 2, 1. At the point 1, 2, 1. So I can write it as dou phi by dou x at the point 1, 2, 1. So here I have 2x, right? 2x. So 2 into 1 divided by 1 square plus 2 square plus 1 square, which is equals to 2 by 1 plus 4 plus 1 is equals to 6 is equals to 1 by 3. Dou phi by dou y equals to, here also it is going to be 2 into 2, 2y, right? 2y. 2 into 2 divided by 1 square plus 2 square plus 1 square is equals to 4 by 6, which is equals to 2 by 3. Similarly, for dou phi by dou z equals to 2 into 1 divided by 1 square plus 2 square plus 1 square, which is equals to 2 by 6, which is equals to 1 by 3. Done. I hope it is clear till now. Now that we have the exact value of dou phi by dou x, dou phi by dou y, and dou phi by dou z, I can write it as del phi at point 1, 2, 1 equals to 1 by 3i plus 2 by 3j plus 1 by 3k, right? Which is equals to 1 by 3, I can take 1 by 3 common here, right? So I plus 2j plus k. I have taken 1 by 3 common here. Now I am going to find the mod of del phi, which is nothing but square root of 1 square plus 2 square plus 1 square, this is 1 divided by 3 square, by 3, just 3, right? So that is 3 square only, that is going to be 9. So 3 into 3. Now I have this as 6 divided by 9. I can write this as 3 into 3. So if I take it out of the square root, it is going to be just 3. So that is what it is. Now I can write as square root of 6 by 3. So the magnitude is what? Square root of 6 by 3. Okay. Hence, we know this del phi, right? Del phi and magnitude of del phi. We have found both at the point 1, 2, 1. Thank you so much for watching. Okay, I'll just give you, the overview. If this is a question given, if phi is equals to log of x square plus y square plus z square, then find del phi and magnitude of del phi at the point 1, 2, 1. So the given question is this, and del phi can be written as this equation, correct? This can be written as this. So here I have simply partially differentiated with respect to x, y and z. Phi is differentiated partially with respect to x, y and z. So I've got 2x by x square plus y square by z. Similarly 2y 2z. Okay, at the point 1, 2, 1, here just substituting at the place of x, y, z 1, 2, 1 respectively. So we get 1 by 3, 2 by 3 and 1 by 3. Done. So once we got that, now at this point, we know that substituting in this equation, okay, substituting in this equation, we get 1 by 3i plus 2 by 3j plus 1 by 3k. So hence, taking 1 by 3 common, 1 by 3 times I plus 2j plus k. Now magnitude is how we are going to find 1 square plus 2 square plus 3 square, 1 square divided by 3 square. So 3 square is what? 9, right? So square root of 1 plus 4 plus 1 is 6 by 9. So magnitude of del phi is nothing but square root of 6 by 3. That is all. It is simple and straight.